Hello students and welcome to my channel Maths Hub. So today in this video I'll talk about points. So if you haven't watched my previous videos on symmetry and asymptote, do watch them because we have covered the 4 important points to trace any curve. So the first video was on symmetry and origin. The second video was on asymptote and today we will talk about points. So let us understand the concept of points. So whenever in a curve we have to calculate the x-intercept or the y-intercept. To calculate the x-intercept, we can put y equal to 0 in the equation of the curve. So that will give us some values of x and that will be the x-intercept. Similarly, to calculate y-intercept, we need to put x equal to 0 in the equation of the curve and that will give us certain values of x which will be the y-intercept in the curve, right? Then secondly, we can calculate for the curves the derivative dy by dx. So if it is an implicit equation in f of x and y and we cannot extract y in terms of x, then we can calculate dy by dx by calculating fx and fy and we put a negative sign in front of it, right? So that is dy by dx. So depending upon the value of dy by dx, if dy by dx is equal to 0, then from there, when we put it equal to 0, so whatever equation we get, that will be a tangent parallel to the x-axis. Similarly, if I put dy by dx equal to infinity, then we get a tangent parallel to y-axis. Now, if the derivative happens to be 0, is greater than 0, if we put it greater than 0, so for some interval x lying between a and b, we will get that y is an increasing function in that particular interval, right? So on putting the derivative greater than 0, we can get that the function y would be an increasing function in that particular interval. Similarly, if I put the derivative less than 0 in a particular value of x lying between a and b, then y is a decreasing function in that particular interval, right? So these 4 points are easily achievable when we put the derivative equal to 0 or we put it equal to infinity or we put it greater than 0 or less than 0. So next is how to calculate the points of intersection. Now we can solve for x and y by simply putting x equal to 0 and y equal to 0 and in the equation, and we can get the points of intersection, right? And similarly, at any point of intersection, we can also calculate the tangent by shifting the origin to that particular point and then equating the lowest degree term equal to 0. Then there is also a concept of multiple points. Now multiple point means a point through the curve through which two or more than two branches of a curve pass, right? So if through one single point two branches of a curve is passing, then the point is said to be a double point, right? So through a particular point when two branches or more than two branches are passing, then that point is a multiple point, and if only two branches are passing, then it is called a double point. Then there are 3 classifications of a double point. We have a node, a cusp, and a isolated or a conjugate point. Now these node and cusp and conjugate points, they are defined according to the tangents. So when we calculate tangents, if the tangents are real and distinct, then we say that it is a node. And the shape of the curve at a particular node is said to be like this. So here you can see that x is equal to 1 is a node and there are two branches of the curve which are passing through it. So this is a double point and this type of double point is called a node, right? So this is one tangent, this is one tangent and this is the second. So here you can see that both the tangents are real and distinct. Now if the two tangents are real and coincident, that means they are the same ones. That means in that case, it will be a cusp and the shape of the curve is like this. So here you can see that x is equal to 0 is acting as a cusp and this is the tangent. The y-axis is acting as a tangent, right? And what is an isolated or a conjugate point? If there are no tangents, if we do not get any real tangents, then that point will be said to be a isolated or a conjugate point, right? So there are 3 classifications of double point, node, cusp, and conjugate points. So if the two tangents are real and distinct, it is a node. If the two tangents are real and coincident, it is a cusp. If both the tangents are not real, then it is a conjugate point, right? So in the curve tracing, we have covered the four important points. So that means S stands for symmetry, O stands for origin, A stands for asymptote, and P stands for points of intersection, right? So with the help of these 4 points, we can more or less trace any curve, right? So thank you so much for listening to me. Believe in yourself and you will definitely do it. And do watch my next videos where I'll show you how to trace any particular curve, right? So the ones who have not watched my previous videos, do watch the previous video so that you get all the points and you are able to understand how to trace a curve. So thank you so much and have a nice day.